Hey guys, Camille here from Prep for Success. Going ahead and taking a deeper look into quantitative comparison questions, more specifically for covering topics within algebra. So within algebra, we'll be taking a look at a variety of different subtopics, but the overarching topic here will be algebra. We'll be taking a look at expressions, linear equations, functions, inequalities, absolute value, etc., and all specific quantitative comparison questions, so we can take a look at the strategy that we want to apply to this type of question. Now, once again, keep in mind we've got our two tips here. Tip 1 is compare, don't calculate, and tip 2 is pick diverse numbers. I can't stress these two enough. So let's go ahead and start with number 1. Here we're looking at quantity A, which is x minus 4 times x plus 3. And then quantity B, which is x squared plus 3x minus 28. So once again, here I'm going to use the advice from tip 1, compare, don't calculate. Instead of plugging in numbers at this point, I can just go ahead and FOIL out quantity A, multiply x with 7, so it's going to be x squared plus 7x, negative 4 with x, and negative 4 with 7, so it's going to be minus 4x minus 28. That's going to give me x squared plus 3x minus 28, which is the same exact thing as quantity B. So instead of calculating, we're just comparing. It's just the same exact expression, but just simplified. So therefore, we know our answer here is going to be C. The two quantities are equal. Great. Now let's go ahead and take a look at number 2. They're saying x is not equal to y. So x is not equal to y. So essentially another way to write that is x not equal to y. And we're comparing quantity A and quantity B. So quantity A is just 1, it's simple enough, and quantity B is y to the x minus x to the y. Well, let's go ahead and plug in some numbers, see if we can make it equal to 1, greater than 1. If we can prove a discrepancy, that's always my first step. So let's just say x is 1 and y is 2. Let's do that. So if y is 2, we would have 2 to the 1 minus 1 to the 2. That would give me 2 minus 1, which is 1. So if I use these numbers that I just plugged in there, x is 1 and y is 2, I get an answer of 1, so they would therefore be equal. Now, the easy part is go ahead and just plug in new numbers and make them not equal. Is there any way I can make these two numbers or two quantities not equal? Well, let's say y is 4 and x is still 1. That would give me 4 to the 1 minus 1 to the 4, which is simply 4 minus 1, which is 3. So now this new value 3 is not equal to 1. Therefore, we have a discrepancy, where in this case, both the values are not always certain, because in one case, quantity A and quantity B were equal when they were both 1. And in another scenario, they were different because B was bigger because it was 3, whereas quantity A still stayed as 1. So we clearly have a discrepancy here. Our answer is D. Now, let's go ahead and approach our next two problems, starting here with number 3 and 4. So for number 3, we've got the absolute value of negative x has to be greater than 5, and x is an integer, as well as x squared times y has to be less than 0, and y is also an integer. And ultimately, we're comparing quantity A and quantity B. Quantity A is 4y, and quantity B is 2. So now essentially what we have to do is just find the value of y, plug that in, and see if it's whether 4y is bigger than 2 or vice versa. Well, taking a look at what we have the absolute value of x has to be greater than 5. So that means x essentially has to be any number that's bigger than 5 or less than negative 5. Because, for example, if we know that absolute value of negative x is greater than 5, x can be essentially just greater than 5, or x can be less than negative 5. Because if x is 6, then we would have the absolute value of 6. 6 is greater than 5. But if x is negative 6, then we have negative 6. That's just 6, which is greater than 5. We can't have anything between 5 and negative 5, like 3, negative 3. That wouldn't be true. So x has to be either greater than 5, like 6, 7, 8, 9, 10, or less than negative 5, like negative 6, negative 7, negative 8, negative 9, etc. So now that we know that x can be either positive or negative, regardless of whether it's going to be a positive or negative number, if we take a look at this, here we've got x squared times y is less than 0. Well, x squared is always going to be a positive number. So a positive number times what kind of number means it's going to be less than 0? Y is going to have to be negative. A positive times a negative means it's going to be equal to 0. Y can't be positive because then it won't be less than 0. So if we know that y is a negative number, so we come to the conclusion y equals negative number. So we can come to this conclusion, then we know that no matter what it is, 4 times a negative number, so 4 times a negative number will just give you another bigger negative number. And any negative number is going to be less than 2 because this is a positive number. So positive is bigger than negative. Here in this case, that's the biggest thing, is compare, don't calculate. We don't have to necessarily calculate here. What we're doing is we're comparing the two. So we won't ever know what the value of 4y is, but all we need to know is that it's going to be negative number. 4y is going to be negative no matter what. So a negative number compared to a positive number, we know quantity b is going to be bigger here. Therefore, our answer is B. Now, next, let's go ahead and take a look at number 4. We've got quantity A and quantity B, simply comparing x for quantity A, y for quantity B. And our expression here is the absolute value of x minus the absolute value of y is less than the absolute value of x minus y. So let's go ahead and just plug in any numbers just to get an idea of what this expression essentially is, the outcome of this expression, as long as we stay true to what they're telling us. So we have to just stay true to this expression. So let's go ahead and plug in some numbers. If, let's say, how can that right side be greater than? Well, let's just say if x is 2, then we would have absolute value of 2 minus absolute value of y has to be less than 2 minus absolute value of 2 minus y. So that means absolute value of 2 minus y has to be greater than. Well, so it seems like y might have to be a negative number in this case. Let's say x is 2, y is negative 1. That's going to be 2 minus absolute value of negative 1 is less than 2 minus negative 1. So that would just be 2 minus 1 is less than 2 minus negative 1 is just plus. So that would be absolute value of 3 is 3. So 2 minus 1 is 1. 1 is less than 3. That's correct. So in this case, we had x was 2, y was negative 1. So we had 2, negative 1. Therefore, we know that quantity A in this scenario is bigger. So far, we got a point for quantity A. Now our goal is to strategically try to pick numbers to see if there's any way that the two numbers are either equal or if y is bigger, if there's anything that we can plug in. Well, we plugged in a positive value for x. Is there any way we can plug in a negative value? Because the whole key thing is to be able to have absolute value of x minus absolute value of y be less than x minus y. Well, how can two numbers that are subtracting be less than the same two numbers that are subtracting? Only if this negative, I'm thinking this negative right here, is canceled out by another negative. So if y is negative, that double negative here is what happened. It turned into a positive, and that's what made it bigger. Because here there's no way you're going to cancel out this negative, because once you take the absolute value on both sides, you're going to have two positive numbers subtracting. That's all you're doing, is just taking the difference between two positive numbers. Here, what you're doing is you're just taking the difference between potentially two positive numbers or a positive and a negative, which would then eliminate that. If x was negative per se, I mean, the only way, let's say we can try x being negative and y being a bigger negative, but in that case, then x is still going to be a bigger number. So there's no way that x is going to be a smaller number. Let's go ahead and give it a shot. Let's say x is negative 2. So if x is negative 2, and we have absolute value of negative 2 minus absolute value of y needs to be less than absolute value of negative 2 minus y. So let's say y could be, so essentially it's going to be 2 minus absolute value of y needs to be less than negative 2 minus another number. So it's going to have to be another bigger negative, or if y was, or y could potentially be, let's make y 5. What if we did that? Then we have negative 2 minus 5. So then we have absolute value of negative 2 is still 2 minus, we said y was 5, so absolute value of 5 is still 5. So 2 minus 5, that's going to be negative 3. So then negative 3, is that going to be less than absolute value of negative 2 minus 5? So it's absolute value of negative 7. So in that case, actually, 7 is going to be greater than negative 3. So here we had x is negative 2, and y was 5. So now the tides have turned. We made x the negative number. We made it negative 2. Y became 5. And we were able to actually prove that y could be bigger than x. So even though it initially looked like that was not possible, what we were able to do is prove that, because essentially we were taking the difference and we saw that negative 2, so if x is negative and we just made y a positive, we just made this a way bigger negative, because then when you took the absolute value of it, 7 was bigger than negative 3. So therefore we know that our answer here is going to simply have to be D, because there's a discrepancy. One time quantity A is bigger when it's 2 and y is negative 1, and another situation is where quantity B is bigger because it's 5 compared to negative 2. So because of that, there's a discrepancy. Our answer choice is D. Next, let's go ahead and take a look at numbers 5 and 6. Starting with number 5 here, we've got another great variety algebra problem, functions. So we're taking a look at quantity A, which is just g of 12, and quantity B, which is f of 7. And then here we've got our two functions, f of x and g of x. So now g of 12 will give me, essentially, I need to use this equation here with g, function g, and plug in 12 for the x, solve. And then for f of 7, I have to go ahead and use the function here with f, plug in 7, and solve. So let's go ahead and solve for these two numbers and compare. So g of 12 will essentially just be 3 times 12 plus 4. So I'm taking this function and I'm replacing x with 12. So that's going to give me 36 plus 4, which is 40. So g of 12 is 40. What about f of 7? So I'm essentially just going to take my f of x equation and replace x with 7. That's going to give me f of 7 equals 7 squared minus 3. So f of 7 equals 49 minus 3, which is essentially going to be 46. So we know that 46 is bigger than 49. That problem is fairly simple there. We know that quantity B is bigger. Therefore, our answer here is going to be B. Now, let's go ahead and take a look at number 6. A certain sequence is defined by the formula an equals an minus 1 minus 5. So we've got this formula here for determining the value of a sequence. So it essentially says that an, so this term for the nth term, is equal to the prior term. That's what an minus 1 means, the prior term minus 5. So they're telling us what a4 is. a4 is negative 12. That's another key component. So if a4 is negative 12, I'm going to set up a sequence 1, 2, 3, 4. And I see here we've got 8 to the 8, so I'm just going to keep going with that. So I got 2. So 1, 2, 3, 4, 5, 6, 7, and 8. So we got our 8 terms. They told us that 8 of 4 is negative 12, so here 4, negative 12. And the formula essentially is telling us that if we wanted to, let's say, solve for a4, which we know is negative 12, so we use the formula an equals an minus 1 minus 5. So a4 in this case, so if we solve for a4, that would be a4 equals a4 minus 1 minus 5, which is a4 we said is negative 12. a4 minus 1 is just a3 minus 5, plus 5 on both sides. We know that a3 would be negative 7. So negative 7. So if we want to go backwards, we're just going to add 5 again, and then add 5, that's going to be a 3. And if we want to go forward, we're going to just keep subtracting 5. So negative 17, negative 22, negative 27, negative 32. So the 8th term here, which is a8, is going to be negative 32. So which number is bigger, quantity A, which is negative 32, or quantity B, which is negative 35? Well, quantity A, negative 32, is the smaller negative number. So the smaller negative number is going to be our answer. So we know quantity A is bigger. Therefore, our answer choice here is going to be A. And for our next two problems, number 7 and 8, starting with 7, here we've got Catsper plays X soccer games a year, and at each game he scores on average 3 goals. Wow, what a superstar. Look at him. So he's scoring on average 3 goals a game, and he's playing X games a year. So quantity A is saying total amount of goals Catsper scores in 1 month. Interesting. And quantity B is X over 4. So we know that Catsper plays X soccer games, and each soccer game he scores 3 goals. So 3x is the total amount of goals he scores in a year. So we want to know how many goals he scores in 1 month. So we take the yearly goals, divide that by 12 to find out how much he scores in a month. And 3x over 12 simply simplifies to 1x over 4, or just x over 4. So we know x over 4 is our answer. We're not going to ever figure out the actual value of that because we don't know how many games he's playing. But what we do know is that when comparing the two values here, quantity A and quantity B are both equal to x over 4. Therefore, we know our answer is C. The two quantities are equal. Now, let's go ahead and take a look at number 8. Here we have Conrad invests $100,000, which earns interest over a period of years. So he's earning this interest over a period of years. Well, let's go ahead and take a look at quantity A and quantity B. So starting with quantity A, we've got the final value of the investment after 3 years at 5% interest compounded semi-annually. So we obviously have to take that value of $100,000 and go ahead and plug in these numbers into our compound interest equation. And then we'll have to compare that value to quantity B, which is the final value of the investment after 2 years at 8% interest compounded monthly. Now let's go ahead and grab our compound interest equation, which we know is A equals P times 1 plus R over N to the NT. And now let's go ahead and just plug in our values. So we know our value P, which is the principal amount, here is going to be the 100,000. So that's just P equals 100,000 for both scenarios, for both quantity A and quantity B. Then here, what we have, the only difference is going to be the years. Here's 3 years, and at a rate of 5%, and compounded semi-annually, so N is going to be 2. So let's go ahead and plug that in. We've got A equals 100,000 times 1 plus 5%, which is 0.05, over 2 to the 2 times 3 power. So it's going to be A equals 100,000. And then 1 plus 0.05 divided by 2. So 0.05 over 2 is just going to be 0.025. So 0.05 divided by 2 is 0.025. Plus 1, so that's just going to be 1.025. So 1.025 to the 2 times 3, which is the 6th power. So now we take 1.025, put that to the 6th power, and that's going to give us approximately 1.159. Multiply that number by 100. So the rest here, I'm just setting up the math and doing the rest in the calculator. I should have A should be approximately $115,969. So that's the approximation here. So that's the value of A. All I did here was take my compound equation, which I'm going to use for quantity B as well, plug in the values, and solve, which gives me the final value of the investment, which is about almost $116,000 over the period of 3 years. Now let's go ahead and take a look at quantity B. So we're going to use our same equation from before, but we're going to plug in different values. Here we have the principal amount still going to be the same 100,000. That stays the same. But now the time is going to be different because here it's 2 years. And the interest rate is going to be 8%. So we put that at 8%. Then we know it's compounded monthly. So that means it's compounded 12 times in a year. And let's go ahead and solve for that. So A equals 100,000 times 1 plus R, which is going to be 0.08 over 12, which is N, to the NT, which is 12 times 2. So essentially we have A equals 100,000 times 1 plus 0.08 divided by 12 plus 1. That's going to give me approximately 1.006 repeating to the 24th power, because that's 12 times 2. So now 1.006 repeating to the 24th power is going to be approximately, just going to put an arrow, A equals 100,000 times approximately 1.173. And then that number times 100,000, just move over, add those zeros. Our final investment value here is going to be about $117,289. Therefore, when comparing the two amounts, we know that quantity B will actually be bigger here because 117,000 is bigger than 115,000. And which is kind of interesting because in this case, it shows that here we had 3 years. However, it was only 5% interest compounded semi-annually. Whereas here we had 2 years, so it was less time, but it was a greater interest and it was compounded monthly. So it allowed the money to grow faster. So 117,000 is going to be bigger than 115,000. So quantity B is bigger. Therefore, our answer here would be B. And last but not least, our two ending questions here, numbers 9 and 10. Let's go ahead and take a look at number 9. At a soccer game, there are 15 more fans than players. The number of players at the game is P. All right, so we know that the number of players at the game is just going to be represented by the variable P. And there's 15 more fans. Well, looks like it's just a scrimmage then, because it's pretty low crowd here. 15 more fans than players. Well, let's go ahead and take a look at our two quantities, quantity A and quantity B. So quantity is just 3P minus 5. And quantity B is the total number of people at the game. Interesting. So the total number of people at the game, let's go ahead and see if we can solve for that. Well, the total number of people to me is just going to be the amount of players plus the amount of fans. Let's say F for fans. Well, we want to try to replace the fans with something that's relevant to players so we can compare it, because we're looking to compare, not necessarily calculate. So players plus fans is the total amount of people at the game. Well, they told us that there are 15 more fans than players. So that means 15 more fans than players. So that means fans is equal to players plus 15. So we can go ahead and substitute for that, giving us players plus fans, which is also known as players plus 15. That's going to give us P plus 15 is 2P plus 15. So essentially what we're doing is we're comparing 2P plus 15 to 3P minus 5. Now, we still have an unknown variable, which is P, the players. So in this case, if we plug in a value for P, let's say there's just there's 2 players. Let's say P is 2. There's 2 players at this game. It's a 1v1 show-off game. And we plug that in, we get 3 times 2 minus 5. That's just 6 minus 5, which is 1. So quantity A would be 1, but if we plug in P is 2 here, we would get 2 times 2 plus 15. That would be 19. So 19 is way bigger than 1. Quantity B would be bigger in this case. But now let's go ahead and plug in another value, like, let's say 40 players, right? Let's say we had a bigger team, bigger game, some subs, some reserves, a coach maybe. Let's say we had 40 players. So if we have 40 players, it's going to be 3 times 40 minus 5. That's going to be 120 minus 5, which is 115 for quantity A. And for quantity B, we would simply just have 2P plus 15, which would be 2 times 40 plus 15. That would be 80 plus 15. That's only going to give you a value of 95. So here we have 115 is bigger than 95. So in one case, quantity A was bigger. In another case, quantity B was bigger. So we clearly have a discrepancy. And if whenever we have a discrepancy, we know our answer here is D, can't be determined. Great. Now let's go ahead and take a look at number 10. Last but not least, we've got the function f is defined by f of 2x plus 3 equals 4x plus 11. All right, interesting. So, of course, not going to keep it simple here. We've got f of 2x plus 3 equals 4x plus 11. So now we want to do is compare f of 7 to 20. Well, we have the equation of f of 2x plus 3 equals 4x plus 11, and they want to know what is f of 7. So all of a sudden, they replaced 2x plus 3 with 7. Well, in order to do that, what's the value of x? So they turned 2x plus 3 into 7. That's what they're doing here. They're just replacing it. So let's go ahead and solve for x, minus 3 on both sides. We got 2x equals 7 minus 3, which is 4, divided by 2. Essentially, x is just 2. So to get f of 7, we would need to plug in 2 into x, because that would give us f of 2 times 2 plus 3, which is just f of 4 plus 3, or f of 7. So if we plug in x where x is equal to 2, then we'll be able to get f of 7. Now, once we know that x is 2, we just go ahead and plug in that value into the function here on the right, which is the 4x plus 11. So let's plug in 2 into that. We've got 4, and we said x was 2, so 4 times 2 plus 11. That's going to give us 8 plus 11, which is 19. So 19 is f of 7, and 20 is quantity b. So what's bigger, 19 or 20? Clearly 20. So in this case, we know quantity b is bigger. Therefore, our answer choice is B.